Hello, everyone. Vector Podcast is here. Dmitry Khan is back on air with a new guest. I'm really excited to talk about like a new tangent in a way, like in how you can do search engines involving hardware angle to it. But I'm curious to hear more detail from Ohad. Hi, Ohad. How are you doing?
Hi, Dimitri. Good to speak with you. We've been talking about it for a long time, so happy to be here eventually.
Absolutely. Like our paths crossed finally. And when we did meet like in person in Berlin Buzzwords a couple of years ago, I remember I came up to your booth and we had a good chat. And back then I was at TomTom. We had a very specific issue with latency of search and felt like we could collaborate in that space. We didn't end up collaborating, but I did bring the idea back to my team. They got excited. It's just like always some other priorities keep popping up and all that. But at the same time, we never spoke like maybe at length about like how you've thought about this technology. So I'm really looking forward to do this today. But as a tradition, we start with the introduction. Could you please introduce yourself, your path, your ups and downs, anything you want to share really, and how you got to this point?
Absolutely, absolutely. So, I'm Ohad. My greatest passion is everything that comes in between data and AI. This is what I've been doing ever since. I'm a product person in my DNA, so I'm coming from a good combination between business and customer needs, and as well as deep tech and developing infrastructure and different architectures. And two topics that I'm specifically excited about is both search and system performance and acceleration. I was dealing with, before founding Hyperspace, I was dealing with different startups, typically here in Tel Aviv. I've been working at the Click Software, for instance. We've been developing optimization engine for scheduling systems. And I also had, in my different companies along the way, always faced challenges that comes in between performance, cost management, and quality. And when looking on search, I was excited about this opportunity. I was excited about pushing the limits, pushing the barriers of existing technology and existing architectures. And in the past 4 or 5 years, I've been managing Hyperspace. Hyperspace is a deep tech startup, and our main target was to fulfill that promise of breaking the performance limitations that currently exist around databases in general, but in search in specific. So this is very brief about me.
Oh, that's fantastic. I think in general, like performance, and maybe this is where we like connect with you, like on that level that I'm also very excited about performance of search engines specifically. Maybe not as broad as databases, although it's all about kind of like your curiosity. Maybe there are no like limits in that sense, but I've always looked at search as well. And I'm curious, like before you started your journey with Hyperspace, have you taken a look at the landscape of search engines? Like, what were your thoughts there? What was missing that prompted you to start working on a new tech?
Mhm. Actually, I think in some ways, unlike most startups, that comes with deep understanding of the domain and a significant problem that needs to be solved. We actually came with a solution first, which is not the optimal way in many ways. We came up with the vision of bringing speed into data analytics and into data workloads. We've seen lots of acceleration systems around the AI, obviously, AI training and then inference, and obviously LLMs. So those compute intensive workloads. And we come up with the thinking of how come these acceleration and new compute systems have not been introduced to databases. And as of today, most of the databases in the world, not just search, but almost all of them, were actually working on general purpose CPUs. And in most cases, you will see performance limitations, either latency, throughput, or cost being affected. So we started learning about the market, and we've seen some projects around Spark acceleration, and some tried to accelerate SQL. But then we thought about two domains. We thought about graph databases, and by speaking with data scientists and graph users, we frequently kept hearing about search. Graph is a promise, graph future looks promising, but back then, around 4 years ago, we constantly heard people complain about their search experience, either in traditional search like Elasticsearch, but eventually, after we started working on that, vector search came in as well and introduced even more challenges into it. So I think we've started with significant domain expertise around performance and optimization and deep tech, but not necessarily around search engines themselves.
Mm-hmm. And like when you say like I think it's like you said, you are like a product guy, right? This is exactly what we product managers do. We first start with like why, or like what are the issues that exist out there, right? Without leading to a solution. Like you said that you discovered some particular challenges with search. Like what were like the top three of them that kind of stood out in those discussions? Or I don't know, top one, top two, whatever you can share.
Yeah, I think when I speak with enterprise customers using search, either in e-commerce recommendation systems, we were really focused around actually financial services, fraud detection, and even quant trading in some points. So we kept hearing a triangle of challenges. I was always talking about it and always hearing about it. I think the first priority of search engineers was always about getting the most relevant results. And I think relevancy was always the top. Even in the events that we participate, most of the talks are around getting the most relevant results and getting the best quality. And even if we kind of looking on search, AI search, and now LLMs and agents, I can see the same trend. The first priority is get reasonable, good results that the user will accept and will see that valuable. But once you tune for optimal quality, and you typically do it in the lab, and then you get into production and you gradually scale, this is where you hit the other walls. It's either you need to spend a lot of money, so your clusters just keep growing, and you end up having a huge bill for infrastructure and compute, or you either reach a wall around what the infrastructure can run in real time. So if you're running offline, everything will probably work fine. But if you need to run in real time at large scale, and scale means either size of data, but also throughput. So this is where we've seen significant challenges to balance that triangle. And then you either need to prioritize, so you need to either not work in real time, so avoid the low latency requirement, or make it a bit easier, let users wait for a bit. But in many studies, we've seen that speed matters to user experience. So you either need to balance performance with accuracy that nobody wants to do, or pay a very large bill to the cloud providers. So I think that's what we've kept here, and that's the problem that we've tried to solve.
Yeah, interesting. So like if I like kind of like replay what you said, those triangle vertices was like cost, throughput, and relevancy, or did I get that wrong?
Yeah, relevancy and quality,
Yeah.
and then performance, which within you can find the size of data, the throughput, the latency, and then cost.
Yeah,
How much
absolutely.
it costs us
Yeah.
eventually. Yeah.
Yeah, today, like when I'm part of managed OpenSearch, we see that frequently in our customers because it's kind of close to Elasticsearch in some place, right? It's still VCN based JVM and all that. But then you're absolutely right that if you really need like real time performance, you usually need to be prepared to pay more unless you optimize heavily what you've done both on index side and on the formula. And I remember like a few years ago when we were running this on kind of like towards web scale search with Elasticsearch in another company. Uh, like just modifying a bit that script, that relevancy scoring formula, if you make it more complex, it actually physically runs much slower, and it doesn't fit into the latency budget anymore. So you end up simplifying and simplifying to the point then it loses the value, right? So it becomes so simple that it doesn't actually do what you want it to do. So you have to trade this constantly.
Actually, exactly, and I think the main thing that we try to deliver. That tension, because what you can run in the query, and let people actually run extremely complex queries, especially now that you need to run hybrid search. You want to combine both traditional classic search functions, filtering, BM25, alongside with vector search, and you want to build extremely sophisticated queries, like real algorithms written in search primitives. And I think that caused a significant performance challenge. And I think that friction, a lot of search engineers needs to deal with that friction, needs to compromise on the search quality driven by the complexity in favor of latency requirements. And our vision was to, if we can bring 10 times efficiency into the search, most people don't need 10 times faster search. 100 or 200 milliseconds are more than enough. But if you can get 10 times more powerful search in terms of efficiency, you can either drive that into cost reduction or into running more complex search queries. And then if your hybrid RAG solution can run, very sophisticated search queries, this is where the real value can come.
Yeah, absolutely. Like I spent a bit of time interacting with the Bing team when I was at TomTom, and they shared some things like how they reason about quality of searches, like huge number of metrics, and obviously latency was the core of that, and they saw a huge impact on revenue when the latency actually degrades because of their scale, it just quadruples, right? And the TomTom itself, the map search, one of the biggest challenges was that you have to search the almost entire index. Yeah, you can limit it maybe with some radius, with some proximity, but you never know what users are looking for. They might be looking, a city on the other side of the planet. We would be searching the whole map on every keystroke because it's auto-suggest, right? So it actually shows you results immediately for a partial prefix. And that's like so much power needs to be spent on the other side, right? On the backend side. You cannot make it too complex on the ranking side because, yeah, it's just too slow, right? And I guess that's when we also started talking to you. And I'm curious, like, having identified this gap, which I think still exists pretty much on the market. Um, like, what was your thinking? How would you solve this?
Yeah, so what we wanted to bring into the market, we wanted to bring a significant like step function. We weren't because that was our value proposition. We wanted to, not to bring like 20, 30% improvement. We wanted to bring like 10x improvement, something significant that would change completely the way search infrastructure is being run. So this is why we've decided to go very, very low into the tech stack. We've obviously Elasticsearch is a very mature product with probably top of software engineers working on that for 2 decades. And we realized that if we want to come up with a significant solution, we need to do it in a very low level way. We need to reconstruct the primitives from bottom up and not even write it in C++ or Rust. We've decided to take the hardware approach and to basically build a dedicated CPU, a dedicated chip for search. When you go into the hardware path, you also have a couple of alternatives. Okay, you can go with GPUs, which is intuitive, but I'm not sure GPUs are such a great fit for data acceleration. I think most projects of using GPUs actually failed. You can build an ASIC, which is probably the most robust way, but can consume a lot of money. You need at least $100 million in investment to develop any kind of ASIC. We tried something new. We tried to leverage the fact that there are cloud-based instances of FPGAs available in the cloud. For instance, on AWS, and we can take them like any other server. For people listening, which are not aware what an FPGA is, we can simply say an FPGA is a chip with no brain. It's empty. It's an empty canvas. You can program it whatever you like. You get all the utilities of an ASIC, but it's an empty canvas. You can program it. And the fact that it's managed by AWS, that means that you don't need it. You don't actually deal with hardware. You write low-level VHDL, so you program the chip in software in a chip design discipline, but you do everything virtually. And back then we thought that this may be a very significant disruption point. And we actually delivered it. It took us some time, obviously, because of the technology, significant technology barriers. When you come up and building a new database, you need to reconstruct everything, the memory path, the indexing engine. And we eventually got into significant acceleration metrics of, and when you optimize, you need to think about everything, not just latency. You need to make sure that you're running fast, but also in high throughput. And query is not enough. You also need to deal with extreme level of parallelism of indexing, because the database keep updating all the time. And then vector came in, and you want to support vectors as well and accelerate vectors. So I think in terms of technology, the complexity is extremely high, and we managed to get into very impressive results.
Oh, that sounds cool. And it sounds like a huge heavy lifting that you did there, because it's very unique to hear that someone actually embarked on a hardware path, to, basically elevate the search performance. Of course, we know stories that Google did it, but they did it for a specific reason. They were growing fast and all that, but not everyone is Google, right? So, and you aimed to produce a product for the mass market. But what I'm really curious about is that, when you embarked on that journey of programming FPGAs, was it a completely new field for you and your team to kind of like learn from scratch or did you have some knowledge already in that space, in the hardware space? Maybe not FPGA, but hardware space in general that would kind of like easier way in.
So definitely, the team is very talented computer engineers. My co-founder and the core team were highly experienced and knowledgeable about performance optimizations, about FPGAs, about chip design in general, FPGAs in the cloud in specific. I think we were one of the best teams worldwide in that matter. Actually, search was somewhat newer to us than actually acceleration and hardware acceleration, but we catch up pretty fast, and we got to learn search pretty well as well, and all the solutions in the market. And something that was very important for me, if you remember, Dimitri, back then 2 years ago, the huge hype around, and you identified that first with the Vector podcast. And I remember coming up into events like Building Buzzwords, Haystack, and others, and immediately like 10 startups building vector databases. And I think those startups really struggle up until today to differentiate themselves from one another. You try to find out what's the difference between this and the other. And I kept avoiding that trap. I wanted us to be very well differentiated. So we focused on performance, and even though might be a niche for the bigger players, enterprise companies, I think that what made us unique and well differentiated than all the rest.
That's interesting. Yeah, indeed. Like when I was discovering this trend, I was driven maybe more by the semantic aspect of it, because I did my PhD like way back in time, in machine translation space, and one of the components of it was semantic analyzer. And I think I still believe that it's much more compact representation of language than what we deal with today, but maybe it's a topic for another podcast. And I agree with you that today it's kind of hard to know why these vector databases, like how they differentiate. But there are also like new kids on the block, like Turbo Puffer, for example. We had an episode with Simon Askelson on this podcast. Like, have you been looking at them? And how do you reason about sort of the trade-offs that they decided to pursue? Because they store everything on object storage, right, as the ground truth. You guys focused more on real-time component. Have you thought about that part in your product design?
I think for us, if I'm looking on the kind of customers that we were able to attract, they were primarily coming from traditional search problems. This is a very matured market with financial services and real-time applications, which are already at scale. When we attracted the market, I think vector search was more preliminary, and people were looking for the easy way to get in, the PLG companies, the plug and play. And I think there was less concern about performance back then. I think we were in some way ahead of the market in terms of performance for vector. So we find much more traction for performance or traditional classic search where systems were already matured. I think in vector, the challenge was more at the early stages. The challenge was more about keeping a large index, terabytes of index, because first solutions were in memory and it wasn't cost efficient. And I think those companies identifying that building an efficient vector index that runs efficiently on disk actually proved to be more successful. And it makes sense if you need terabytes of data. I think now we're starting to see a shift in that. And I think the main shift that I see that can create a change um, is around the move from chatbots and copilots into autonomous agents. Because when you have an agent that's employing sub agents, eventually your throughput can easily grow exponentially. Instead of one query, you may have 20 queries. You can get into agentic loops that require extremely um, more queries, extremely more retrieval, and you need that fast because each loop actually waiting for to initiate the next one, and the GPU eventually sitting idle waiting for the result. And I think in some ways agents would significantly highlight those challenges again in the next couple of years.
So in other words, what you're saying, if correct me if I'm wrong, but like this agentic shift only resurfaces the importance of high performance search engine, correct?
Yes, and specifically at high throughput systems, I think throughputs would make AI search performance much more needed. There are some more trends that I can kind of guess. For instance, the move from large language models into SLMs. I think if I'm looking on more companies trying to use small language models that extremely faster, that can deliver, response within maybe 400 milliseconds, then the retrieval part, especially in agents that need to run maybe 10, 12 retrievals in one user interaction, would make search performance the new bottleneck for AI.
Yeah. Or like if
If
it's
that
not,
if that makes sense.
it does. Because again, if you didn't solve the performance bit, like if you're not like looking constantly after that, then be prepared to overpay, correct? Like when you deploy this en masse, um, you cannot really control what agents are going to do.
Yeah, in some cases, we've seen some use cases that even paying more would not solve the problem. As well as the problem, the workload can be parallelized. Yes, you can bring more servers and you can scale by that. The one exception that I've seen is when your query is becoming more complex. When the query is involving multiple filters. And then you also want to combine that with some ranking and also with some vector search. And you want to run all together at high throughput. This is where additional servers might not be enough because those kind of problems become compute intensive and not highly parallelized and distributed across large clusters. So you either need to pay a lot of money or you either face a wall and then need to compromise on performing a more naive retrieval.
Yeah. Or like undo some features, and so on and so forth. And hence was my question. Again, by the way, Turbo Fluffer is not sponsoring this podcast yet. But what I'm curious about is that what they did is that they thought, okay, if adding vector search a feature will require you paying like 5 times more a month just for that feature, right? So you used to pay like I don't know, $6,000 a month for Postgres, and now you add a vector search. On top of this, you need to pay 30K like a month. This is just outrageous, right? Just to bring one feature. So they thought from first principles, let's just push everything to object storage. It's much cheaper, but then they tilted the balance towards higher latency. Like at peak, like P99 latency they just recently published, it can go well above over a second, right? For the cold query, because you need to do a couple of round trips. It's not in your cache, it's not on disk, it's not in memory. You have to go to the object storage. But when that doesn't happen, when you do have the cache that covers the workload, then you actually enjoy the same latency that you would enjoy with the stateful search engine, but you pay substantially less comparatively, right? If you would compare it to storing everything in memory and on disk, right? So
Yeah.
how do you think about that approach?
I think for us, at the beginning, we were really focusing on latency, proving that we are 10 times faster. Then later on, I kind of eventually understood that latency is a tool, is a requirement. Is you have a budget like you said before. It's either your budget is 400 milliseconds if you are okay users to wait a bit, or your budget is 100 milliseconds if you are an automated fraud detection company, or it might be even 10 milliseconds if you are extremely fully automated and maybe do trading and stuff like that. But eventually, it's a budget that you need to meet. And I think now that things are getting into production, there were lots of experimentation in the past 2 years, but now enterprise customers are getting those into full-blown production. I think the next bottleneck is that friction between performance and accuracy and obviously cost. So we started looking on cost per query as the main metrics. Because if you are highly efficient and you can, instead of doing 100 queries per second, you can scale into 1,000 queries per second that meet the latency budget, so you are 10 times more cost efficient. And that is way more dramatic, especially again in agentic era when you have lots of retrieval queries getting into your database.
Yeah. So when you think about the agentic kind of future, or maybe it's some partially the presence already, do you somehow differentiate between agent setups where real time will be an important component versus, setups where you run like a long running task? It takes, I don't know, a week. It doesn't matter as long as it completes. And there, the real timeness is less overall. Or is this completely different? How you think?
Yes, I think in many ways this is similar to SaaS applications that we already familiar with. There are offline applications and there are real-time applications. The real-time applications typically involve a user waiting for the result. If this is a fraud detection company, there is a user waiting for the transaction. And people don't like to wait. If this is an e-commerce search engine, someone is waiting for the page to load, and lots of research found that people don't like to wait more than 300 milliseconds, and from 300 milliseconds and beyond, you started to get retention and people leaving. And even today, when we are using chatbots, we are tolerating seconds of latency, and that's okay. And I think same will go to agentic workflows. Some can be done offline. So if I put myself an agent that scan my emails, highlight the important ones, I don't care about latency. Do it at your own pace, do it accurately and cheaply, and I'm fine. But if this is a real-time application and the agent needs to make decisions in real time, so speed matters and latency matters. And let's remember, again, if the bottleneck is throughput and cost, so performance is still important. If even if I have an offline agent system that runs at extreme throughput of thousands of queries per second, it still consumes compute. And if I can do it more efficiently, I will save money, even though latency is not a priority.
Yeah, absolutely. Like in the limit, a better performing system will probably be and more cost efficient is kind of like more economic to run. And then experiment with more features for sure. like I'm curious, like what were your learnings in Hyperspace as you built, these programmable chips, right? And you brought the search workload onto these chips. Um, both from product perspective, maybe technology perspective. Did you feel that you're ahead of curve, like you said? Like, can you unpack a bit that part? Uh, yeah, and then we'll talk a bit about the business side afterwards.
Yeah. I think to start with, there are lots of learnings, lots of conclusions, lots of ideas that I can take with me to my next innovations. But for me, the most important thing, as a founder, as an entrepreneur, innovator, I think it all comes down to product market fit. And I think product market fit is driven by two main things: the problem that you are trying to solve, or the opportunity in the market, and the solution that you bring with you. I think for us, the problem was and still significant. Like we hear lots of people complaining, lots of friction, lots of people trying to optimize something which is already well optimized. So I think the market gap was there and it's still there, and it's only will grow bigger. I think the approach for the solution is something that would probably I would approach differently, because the main challenge when you try to bring a value proposition which is around efficiency, um, the companies that will most suffer from that are enterprise big customers, and when you're looking on those enterprise customers already running in production, heavy workloads of search, AI search, agentic workloads, those are mission critical, and they are extremely scared to bring on new technologies. It has to be bulletproof. It has to be extremely matured before they will even try it. And I think you mentioned about after we met at Berlin Buzzword, you proposed that for the team, and I guess that was the reaction. We have something working now. Um, why should we take such an enormous risk to try new technology that is not yet proven? And if you want to come up with big, significant level of disruption, you need to come up very big and very strong to do that. Or you need to catch that in a much earlier stage. People don't mind to try new stuff when they developing new stuff. But in order to replace something which is existing, working, mission critical, running on hundreds of machines in production, this is a different ballgame. And you need to come well prepared to this kind of discussion.
Yeah, absolutely. I think, but it's still like if you kind of like remove which are not easy to remove, but things like these things are not invented here, therefore we don't trust them, right? So like it will take like years for some enterprise to, like you said, even begin evaluating things, minus all the time that spent in Slack, because I don't mean the messenger, I mean that you are wasting time in planning and not actually building the thing, right? The problem of performance is still there, right? It's right there at the core. Like specifically with TomTom, without naming the clients, they're all under NDA and contractual obligations. But like there've been cases where a customer comes in, they have a very big workload that hugely depends on performance, and they're asking us if we can shave off, a couple of 100 milliseconds from the latency. And we've realized that the only way to do that was to throw more servers at it. And then it comes at net comparison, and you realize, nope, that's not a good way, right? Yeah, you can get that customer, but you'll pay more, and so you won't earn much. So the problem of what you've nailed is still there. So I'm curious, like when you say about product market fit, what else was there as a friction besides this? So was it like the core friction that enterprises were your target customers and therefore they would not like jump on this immediately? But you did end up having customers, right? After all, were they like smaller
Yes,
companies?
yes. No, no. We had customers and we targeted enterprise customers. We never, well, so we had contracts, even large contracts with leading companies in fraud detection, in quant trading. Those were the areas. I think when you come up with deep technology, acceleration technology, even hardware-driven acceleration technology, you need to decide your go-to-market strategy and your path to the market. Is either you focus on, the top 10 companies running search today, or even the NVIDIA of the world, or Google, and you build a solution which is tailor-made for them, the Booking.com or those kind of players that runs, thousands of machines. And then if you go that path, your technology challenges are easier because you can customize a solution for a specific application. And then you can focus your business development and go-to-market strategy toward that direction. We didn't took that part. We wanted to democratize that. We wanted, the idea was that because we are running on cloud-based instances of FPGAs that are basically available for everyone, our vision was to make those search performance available for everyone. So we've taken the longer, more challenging path to build a generic database, which is more complex. But we haven't realized the risk factor that enterprise would look by transitioning from one solution to another. So for me, that was the main challenge, the challenge of bringing the level of maturity that those enterprise customers need in order to trust you and move. Eventually, we needed to raise maybe 4 or 5 times the money that we've raised in order to reach that level of maturity.
Oh yeah, absolutely. But have you also thought, like at Ivan, we are kind of like in a similar ballpark, because not exactly on the hardware part, but I mean in terms of figuring out how to actually bring these customers, right? And it was like a long journey, and the company crossed like 100 million ARR last year. It's like you need just to be super meticulous and like continue like running with that SLG and PLG motion, mostly SLG, I guess. But have you thought about, like, if you take the analogy, let's say, of ChatGPT, the large language models existed for quite some time before ChatGPT actually happened. And what did they do? They actually innovated on the interface, right? So they said, hey, now you can actually change your workflow from what you used to do in your 10 blue links approach to asking anything what's on your mind and getting back the answers, right? And all of a sudden, no one could predict this, right? They invented a new UI that actually skyrocketed. I think themselves didn't predict that. But from that time on, we now see a couple of more players that basically coexist. And recently I heard that Anthropic actually eclipsed OpenAI in terms of the value of the company, right? Who could have guessed that people who would leave OpenAI create a company that is more valuable than OpenAI itself, right? But these things happen. But that's like a different scale of things, but like more down to earth. Have you thought of kind of like packaging your product in a different way where you could attract maybe not big enterprises, smaller companies, mid-size, that would actually have that very acute problem that you've solved, but wouldn't have the capacity to build a solution for it?
I think you're touching probably the most important thing. I think you nailed it. And this is not just a hyperspace problem. I think it's the problem of most of the search infrastructure solutions right now. If you look there are so many databases for search. And all of them are databases, infrastructure players, focusing on the technology. And I think what OpenAI did, and most of the successful technologies that is to cross that and go upper into the value chain, is to eventually bring an application, is to go all the way and provide a significant value. If I see an opportunity right now for most of those search experts and search vendors, is to climb up into the application layer and bring an end-to-end solution for a real problem. For instance, if we're looking on the transition of the challenges from bringing more accurate, robust models into context, I would want to see, search players, search experts starting to bring end-to-end solution for context management. How to manage context in an efficient way, how to manage memory in an efficient way. I'm hearing lots of talks about company brain, how to build company brain in the best way. And you know what? Why limiting company brain just to company? For me, the model and the thinking layer of AI, which was there for the focus in the last 2 years, it's solved. It's solved. Models are strong enough, but the memory part and the context part, this is where the focus is going on. And in many ways, this is a retrieval problem. This is built on search. Even if we choose to build a company brain, remembering everything that the company is involved with, or even that memory layer can be highly personalized for me as an individual, and also remember all of our past interactions. Eventually, this is built on the search fundamentals. And I think that's the greatest opportunity to take to go up from the infrastructure layer and provide an end-to-end solution application that works which is a key part in agentic workflows.
Yeah, that's a very interesting topic as well. And is this something that you keep working on nowadays? Is this something that entices you as a next big challenge for you as an innovator?
Yeah, I think I'm finding myself again in the most exciting phase in entrepreneurship, in being a founder, which is the ideation phase. You don't have any boundaries. You don't have a team. You don't have a product and roadmap yet. You feel free to jump in between ideas. And I think if I'm looking my expertise and my passion, which is anywhere between search, performance, I'm extremely excited about those kind of elements. After the hype, after the excitement, with the transition from chatbots into agentic systems, I think managing the costs, managing the efficiency, and optimizing those workloads is what excites me most. And I keep brainstorming and ideating around those topics, either around retrieval and efficient routing and context compaction. On all of those kind of concepts are keeping me up at night and excited about future opportunities.
Yeah, that sounds exciting, and I think it's both challenging in terms of what you mentioned. The primitives, the building blocks are still there, right? Like make it performant, make it economic, but it's also getting kind of like closer to where this whole thing potentially is going, and users will need memory. Like the other day, I was chatting to one of our solution architects, and he said that, hey, I spend now a lot of time tuning the search engine for a prospect. It would be so cool that I could just give that knowledge to another solution architecture in another geography, right? because they are obviously not with me. They're not following what I'm doing. And just sharing the documents or sharing like Slack messages is not the way to go. You cannot actually kind of like give them knowledge through that. You'll have to spend a lot of time again replaying what you did and so on and so forth. It would be cool if we could give like we could do the job like clone yourself and give your clone to someone, right? So that would be maybe the extreme version of uh, context memory and all that combined.
Exactly. When I'm looking into the future, and comparing that into the past, we had the internet revolution. Things significantly well. Things in many ways remains the same. Okay, we had marketing channels before the internet, and then we had marketing challenge after the internet, but it completely changed and evolved into the internet. Then we had another transformation going from on-prem to cloud, and company had to rebuild the entire infrastructure for the cloud. And now I think we are witnessing a similar transformation, building everything for AI and building everything for agentic systems. So you need DevOps systems, you need observability system, you need optimization systems, but you cannot use the ones that you used before. You need to reconstruct those, and you need to tailor-made those to be optimized for in the new world.
Yeah, that's very interesting, like the angle of everything changing. And that also means that it's a place for like hundreds of thousands more companies, right? Kind of innovate and tackle these problems. Is there something that you want to share or like address the audience of the podcast? Anything that, I don't know, take away lesson from your startup, anything that is is worth sharing on your side?
For me, I think the search community is an amazing community. I got the privilege to get to know it, in the past 5 years, mostly in events, in podcasts like that. And I think those are extremely experienced, talented practitioners, dealing with search for 20 years. I want to thank that community because it was an opportunity for me to learn. And it was an opportunity for me, to identify market trends, identify needs. So I just encourage everyone to keep innovating and keep inventing new things. And feel free to reach out if you have an interesting idea that you want to bring into life.
Oh yeah, absolutely. Thank you so much. I have to say that, even though we didn't go super deep into how did you program that FPGA, like was it something that you can easily copy to other companies? But I think that's also something, for those curious minds, you can go and research, but or contact Ohad. But what I want to say is that I really enjoyed the conversation because it was so deep on other tangents, which I think are very important in the modern world because we keep reinventing the thing. We don't know yet where we will all end up, right? And also, like, if you look at even these biggest players like Anthropic, OpenAI, I don't think they figured out the product market fit either because they burn too much cash for the value that bring. The value is massive, but I don't think they realized how to actually make it sustainable yet, right? And so it feels like we are like in this journey together, figuring these bits from different angles. And I'm really happy to see you continuing on that path. And all the best to you. Like good luck, really, on that. And I'm looking forward to record another episode where you will tell us, hey, we've built the product. Please try it. And this is what I will try myself.
Absolutely, that would definitely close the cycle. I'm extremely happy to come here and speak with you. I know we've been talking about it for a long time, so I'm happy that we finally had the chance to do it.
Absolutely,
and keep doing that. Keep doing those great episodes that we can all learn from. Thank you so much, Dimitri.
Yeah, thank you, Had. I feel like it's potentially a new wave of topics that I was kind of quietly waiting for after the first big wave of vector databases. We touched on this. Maybe the next wave is emerging, and with guests like you, we can explore more of this. So thank you so much for your time. Really enjoyed it, and have a great day.
You too. Thank you so much.
Thank you.
Bye bye.